Uh, ఓకే, మనం క్లాస్ స్టార్ట్ చేసుకుందాం. మీకు డౌట్స్ ఏమైనా ఉంటే లాస్ట్ సెషన్ అయిపోయిన తర్వాత 5 to 10 minutes ఉంటుంది, అప్పుడు మీరు డౌట్స్ అడగచ్చు. చాలా కొంచెం జాగ్రత్తగా వినండి. సో ఓన్లీ ఈరోజు మనం బేసిక్స్ మాత్రమే డిస్కస్ చేయబోతాం.
ఓకే సార్.
So once again, good afternoon to all. Today we are discuss about our first chapter, as the fundamentals of electricity. So already in the last class we have discussed about a complete pattern of examination as well as syllabus of the BEE subject. Today onwards we will discuss about the first chapter, that is the fundamentals of electricity. So majorly in fundamentals of electricity we discuss about two topics. One is a DC and second one is a AC. So in case of the DC voltage and Ohm's law, next effect of electric current, units of work, next heating effect, electrical power, formula for power and units, next power rating of home appliances, primary and secondary cells, series parallel connection, internal resistance of battery, ampere hours and watt hour efficiencies, electrical characteristics of lead acid cell, next conditions of fully charged cell. These are the DC fundamentals. So next we discuss about the AC fundamentals. In case of the AC fundamentals, we discuss about what is the alternating current, how it will be generated, next concept of a cycle, what is we are called as a time period, next how can frequency can be defined, what is the amplitude of sine wave, next we discuss the formulas, next forms of different equations for EMF, average value, RMS value, definitions of form factor, peak factor. Next finally we discuss about phase and phase differences. So the first chapter slightly length as compared with the other chapters. Mostly it is a theory basis. So just we have a few calculations related to the average value, RMS value, form factor, peak factor. These we are called as a problematic session. Just 3 to 4 steps the answer will be we can solve. So these are the fundamentals. First we discuss about the DC, then we discuss about the AC. So before going to the topic, so first we know about the basic things. First we think about what is the structure of the power plant or the power system, right? So in case of the power system, there are 4 roles will be placed. First one is a generation, second one is a transmission, third one is a distribution, and fourth one is a utilization. So power system is categorized into 4 types: generation, transmission, distribution, and finally utilization. So first generation. So generation part we are called as a power plant. Power plant will be we are called as a generation. Next second one is a transmission. So transmission, so this part will be we are called as a transmission. By means of a transmission lines, the power is transmitted from one place to another place. That will be we are called as a transmission. Next distribution. Distribution is nothing but whatever it will be received, that will be distributed into several peoples. So this part will be we are called as a distribution. Last final is a utilization. So utilization is nothing but what is the power is consumed by means of the consumers. So that is we are called as a utilization. So these are the major 4 topics will be is covered in case of the power system structure. So first we think about the generating stations, next transmissions, then we go for the distributions, and last finally we go for the utilization. So these are the major topics we are covered, and then we go for the small definitions related to the electricity fundamentals. First we see the DC fundamentals, then we go for the AC fundamentals. So first part is a generation. So generation we are called as a power plants. So in case of the power plants, the power is generated by means of a alternators or DC generators. So there are two types of power plants will be there. One 90% of the AC. So there is practically no DC power plants will be available. So why means initial days whenever the power is determined, only DC power supply is available in the 19th centuries. So 1910 or 1920 centuries లో పవర్ అనేది డిటర్మైన్ చేయడం జరిగింది. అప్పుడు DC పవర్ మాత్రమే అవైలబుల్ ఉండేది. సో దెన్ ఆఫ్టర్ another scientist will be invented the AC power. So first we think about the drawbacks of AC and DC, then we go for the further topic. So DC is nothing but we are called as a direct current. Direct current. So if the frequency is 0, so that will be we are called as a direct current. So AC is having some frequency. So later we discuss about that. So what are the major drawback of DC? It cannot transmit for the long distances. Only it is limited for the 50 kilometers. If the distance is increases, then losses will be increases. So because of that reason, so mostly instead of DC, the AC current will be we are used. For example, in power station, generally 11 kV or 15 kV. So that is a maximum range 11, 13, 15 kVs. So in this ranges only the power can be generated. So then it will be step up and step down into different categories, and finally it will be reaches to the consumer. Just we are assuming the power plant will be produces the 11 kV. So then if the distance is 50 kilometers, then the losses will be maybe 8 or 7 kilowatts can be 7 kV. It is reaches to the directed generating station to the consumer. But whenever the distances is more than the 50 kilometers, so the same amount cannot receive for the consumer. So it may be reduces to half of, means 5 kilowatts can be obtained or less than the 5 kilowatts can be obtained. So these are the major drawbacks of the DC distribution. So to overcome that problems, the AC power distribution nowadays we are used. So mostly 99% of the power distribution by means of the AC only. So that is a major advantage. What is a major advantage? Nothing but it can be transmit for the long distances also. 400, 500, 800. So how long it is possible, the transmission can be possible with minimize the losses. So the major equipment will be placed involved, that is we are called as a transformer. So this is we are called as a symbolic representation of the transformer. So it will be plays an important role in AC power distribution system. So it will be step up from lower voltage to higher voltages. Similarly, it will be step down from higher voltages to the lower voltages. So this is the main heart for the entire power system. So as a human body, heart is the important one. So similarly, in case of the power system, the transformer will be plays an important role. It is a heart. It is a heart of the power system. So by means of this device only, the powers can be converted into one level to the another level. So this is about the generation. So generation is nothing but where the location the power is generated, that is we are called as a generation station. Next, the low voltages. So whatever we are producing 11 to 11 kV, 12 kV, 13 kV or 15 kV directly not transferred to the distributor because the distance is more. So even AC or even we are using the AC, the power losses will be takes place. So there are some conditions will be there. So whenever AC is passing through the long distances, the power can be reduced by means of the environment conditions. Next, ground resistance, ground earthing. These are all the factors will be affecting on the performance. So because of that reason, the power cannot directly transmit to the generating station to the utilizer. So there are some steps will be there. So the transformer we are using. So where the 11 kV is stepped up into different manners. So 220 kV or 500 kV. So these ranges the voltage can be step up. Basically it is producing the 11 kV only, but it will be step up into 220 kV and 500 kV. This is a high voltage, almost 11 220. So 200 times of the voltage can be step up. Why these ranges will be we are producing nothing but to minimize the power losses. So AC power distribution is expensive as compared with the DC, but we have the major advantages. Because of that reason we are using the AC power, right? So the second step, it will be step up into 220 kV or 500 kV. So this step up voltage can be transmitted by means of a towers. So these are all we are called as a transmission system. So there are two types of systems will be we are used. So depending upon the voltages, but majorly 3-phase 6-wire system will be we are used. So we can observe in transmission lines also higher towers, aluminum, silver color towers can be appear roadsides. So those will be we are called as a primary transmission system. So 3-phase 6-wire system. So each 2 wires will be carries the 1 phase RYB. So that will be discussed later, right? So this is a transmission system. Transmission, దాంట్లోనే ఉంది word itself says trans as a mission. So that's why we are called as a transmission lines. This is a second part. Next, third part. So third part lo whatever the voltage is step up into 220 kV or 500 kV. So we cannot directly utilize it. So there is a need to step down the voltages. So from 220 to 500 kV, it will be stepped down into 132 or 66 kV. So this is mostly we are using the multipliers for simple calculation point of view. So 66, 11 kV, 22 kV, 132 kV. So this is a phenomena we are considered for easy calculations. So there is no specific reason why only it will be standard for 130 to 66. So as ever convenient, but simple calculation point of view, just we go for the these ratings only. So where the 220 to 500 kV is stepped down into 132 kV to 66 kV, but directly it cannot utilize it. Then again it will be stepped down into 66 kV to 11 kV. So again 11 is the step down into 400 volts and 230 volts. So finally it will be reaches to the our homes. So in power in generating station, the power can be produced as a 11 kV. So to transmission point of view, the 11 kV is step up into 220 kV and 500 kV. So this high voltage is transmitted by means of the transmission lines. Then after it will be stepped down into 132 kV or 66 kV. Then again finally it will be stepped down into 11 kV. So finally from 11 kV to it will be stepped down into two voltages. That is a 400 volts and 230 volts. So 400 volts generally we are used for the agriculture applications as well as the small industry applications. 230 volts we are used for the domestic applications to run our TVs, refrigerators or electronic goods, whatever we are using. So that is utilized these 230 volts. 400 small scale industries and agricultural motors can be run. So 11 kV directly a medium scale industries can be utilized directly the 11 kV. So in this picture only we are considered about the home or small business. So 230 volts is sufficient for home appliances. So this is a structure of the power system. So first generating station, then second one is a transmission, third one is a distribution, and finally is a utilization. So these are the four parts will be takes place in case of the power system. So these are the basics. Next, already we discussed about classifications of current. So it will be classified into two types. One is the AC current, second one is a DC current. AC is nothing but alternating current. DC is nothing but direct current and alternating current. These are the representations of waveforms. So an x-axis we are taking the time and y-axis we are taking the magnitude. So for example, if we are considered for the alternating current, the waveform will be start at 0 and it will be reaches to the positive maximum and it will be reaches to the 0 and it will be go through the negative maximum and it will be reaches to the 0 value. So this portion will be we are called as a cycle. We are called as it is as a cycle. A number of cycles produced for a time period, then that will be we are called as a frequency. So those things will be we are discussing the later. But this is a structure. Alternate itself says there is no constant. It will be starting from 0, reaches to the maximum and come to 0 and enter into the negative coincide. Next it will be reaches to the 0. There is no stability of magnitude. So if you draw the positive peak and negative peak, so then we can observe here. It will be once reaches the maximum peak and it will be reaches to the maximum peak at the negative side. So it is continuously repeated. So direct current it is does not changes with respect to the time period. For example, we are taking the time on x-axis and y-axis we are taking the magnitude. The representation of the DC is constant. So how long the time is various. For example, there is a 5 seconds and example there is a 10 seconds we are considered 15, 20. So whatever the time period we are various. The magnitude of the current is does not changes. So that's why it is we are called as a direct current. But in case of the alternating current, the magnitude of a current is changes with respect to the time period. For example, a maximum magnitude, it is a 5 seconds, it is a 10 seconds, this is a 15 seconds, and it is a 20 seconds. So every 5 seconds, the magnitude is changes. At 0 degrees, 45 degrees, 90 degrees, next 180 degrees, up to the 360 degrees. So means the magnitude is changes with respect to the time period. So because of that reason, that is will be we are called as a alternating current. The word itself says alternate. Alternate and means continuously it will be various. Direct, there is no direction, there is no alternating. So directly it will be reaches to the destination. So these are the differences between the AC and DC. Next, we go for the introduction. So first we think about the current, then we go for the rest of the topics. Right. Up to here it is clear. So you can unmute yourself. Please someone respond.
Note.
Okay, it is clear?
Yes, sir.
Right.
Yes.
Okay, ma. Okay. Next ఇప్పుడు మనం టాపిక్ లోకి వెళ్దాం. So first we think about the electric current. So this is an important question. So ask for the 1 mark. So mostly it is repeated question. So first we think about the what is electric current and their characteristics. Then we go for the further details. So electric current is nothing but the rate of flow of electric charges. Simple definition, the rate of flow of electric charges. That is we are called as a electric current. So it is measured by means of the amperes. That is we are called as a coulombs per second. It is invented by Andrew Marin Amperes. The scientist is discovered the current. So in his name the units is measured as a amperes. Next, it is in invisible form. So electricity is always invisible form, but we can experience of its effects. So మన పవర్ని టచ్ చేయడానికి అంటే ఫిజికల్ గా చూడడానికి అనేది ఇంపాసిబుల్, బట్ వీ కెన్ ఎక్స్పీరియన్స్ ఆఫ్ ఇట్స్ ఎఫెక్ట్. సో ఎప్పుడైనా మనం లైవ్ కండక్టర్ టచ్ చేసాం అనుకోండి, సో వీఆర్ గెట్ ఎక్స్పీరియన్స్ ఆఫ్ ఎ షాక్. So that is we are one of the character of the electricity. So conductor నుంచి పవర్ అనేది వెళ్తా ఉంటుంది, బట్ ఫిజికల్ గా దాన్ని మనం చూడలేం, కానీ దానికి కనెక్షన్ అనేది మనం మేక్ చేసినప్పుడు దాని ఎఫెక్ట్ అనేది మనం చూస్తూ ఉంటాం. సో దేర్ ఈస్ వేరియస్ అప్లికేషన్స్ ఫర్ ఎలక్ట్రిసిటీ ఆర్ ఎలక్ట్రిక్ కరెంట్. సో ఫస్ట్ వన్ ఈస్ లైటింగ్, heating, coolers, home appliances. So these are all can be run by means of the electric current. So simply we cannot live without electricity. So in our daily life we are utilizing the electricity in various applications. So from the morning to the evening session or night session, everything is working on the electricity only. So rice cookers, makers, next refrigerators, iron boxes, so our mobiles also working on the electricity. So we cannot imagine without electricity in our life. So this is a important thing, right? So next first we think about the what is the voltage and current.